Uh, we will study chapter 8. In chapter 8, actually, we will cover with a simple circuit, such like voltage source and resistor, and the second adding one energy storage device, such like a capacitor or inductor. So one circuit has only one capacitor or an inductor. In chapter 8, we will discuss about how to solve the electric circuit with one capacitor or one inductor. This circuit we call simply the RL circuit or the RC circuit. So this circuit called the first order circuit. You remember that there are some circuit resistors in this way here. Then to solve this electric circuit, we make the algebraic equation based on the voltage and the resistance here, the R values. For example, to get that value is V out is R1 plus R2, R2 V in, such like here. So to solve this electric circuit, we derive this algebraic equation, then solve the V out based on this equation. In the other hand, in the case of the circuit has one capacitor or inductor, then just like the circuit here, the resistor and the capacitor, then this voltage or current can be represented in other type of the equation. That is the first order, the differential equation. Maybe you will learn the differential equation in the engineering mathematics when you are freshman. So we will use that. The order of the differential equation is the first order because there are only one capacitor or one inductor. If there are two capacitor or inductor case, then the order of the differential equation is 2, second order differential equation. We will cover the second order differential equation based on the RLC circuit is in the next chapter is 9. Anyway, in this chapter we will discuss about how to solve the electric circuit contains only one capacitor or an inductor. So this is the first differential equation. Do you remember how to solve the first order differential equation? The solution of differential equation consists of two solutions. Is natural response or forced response. Maybe when you are studying the engineering mathematics, we'll study about the natural solution or the forced solution or homogeneous solution and non-homogeneous solution, such like that. They're the same things, but the expression is different. In the case of the electric circuit, the voltage or current, the decayed as naturally, is the homogeneous solution, and in the voltage or current is defined by input voltage or input current. So the response based on the input, so we call that is a forced response. So anyway, the transient solution of the time domain, the current or voltage in the electric circuit, it has a capacitor or inductor can be written in the natural response and the forced response. Then these input voltage or input values can be a constant or exponential or sinusoidal. We will discuss about what would be make a difference when the input is constant, exponential, or sinusoidal. As a result, in conclusion, we will tell about that, but the only different thing is the forced response. So natural response does not affect type of the input, but actually this input type is input type determine the forced response type. And we will discuss about the abrupt change in RL or IRC circuits. We will analyze the first order circuit and the step function or sequential switches and use analysis based on the KCL and KVL. But different thing is the circuit has a capacitor or inductor. Then we will use the KCL or KVL or mesh equation or node equation, whatever it is, you can use it. But different thing is the equation is different. Circuit has a register, only registers. Then the equation to represent the electric circuit is the algebraic equation. But the circuit has a capacitor or inductor. The equation to represent the electric circuit is differential equation. In the case of the circuit with one capacitor or one inductor, then the differential equation is first order differential equation. I will introduce how to solve that. And don't worry about how to solve the first order differential equation. I forgot it. It's okay. I will tell you how to solve the first order differential equation very simply. The first order circuit. What is the first order circuit? In electric circuit, first order circuit is defined as the electric circuit with the capacitor and the inductor. Then this electric circuit represented by the differential equation. So the order of differential equation is the same with the number of capacitors and inductors. If circuit has only one capacitor, then the differential equation to represent the electric circuit is first order differential equation. When the circuit has one capacitor and one inductor, then the voltage or current in the electric circuit can be represented in the second order differential equation. Why? The circuit has a two energy storage element, one capacitor and one inductor. So especially when the circuit has only one inductor or one capacitor, then we call that the voltage or current can be represented with the first order the differential equation. In the case, the circuit is called the first order circuit. In chapter 8, we will deal with about this first order circuit and how to solve the first order circuit and what is the characteristic of that and some sequence to solve the first order circuit. This is a first example for you of the first order circuit. The example. Circuit looks like here. This is input values. The input is a kind of sinusoidal values. What's the meaning over here? Maybe voltage is defined in this way here. In case this is time t, and maybe if set at 0, then we will describe the here. Maybe this is a waveform over here. This is a VST, and that value is A, that value is minus A, and that value is about about 2 pi divided by 1000 seconds here. The VS looks like here in this waveform. This is a sinusoidal waveform. Then the question is, we want to know about this voltage. This voltage is across the capacitor. So we want to know that, how to get the values here. So that is the question. That is a goal of this chapter. How to get the voltage here. And more, before t is smaller than 0, then R1 and R2 connected here. But at the instant t is 0, the switch is closed in this way here. Then t is larger than 0, and from 0, R2 does not affect this circuit because this is this switch, because of this switch. So in this case, we will we'll define in several electric circuit based on the time. For example, we will do here. So the circuit looks like here. So plus, minus, R1 and R2, and there's a switch here. When T is 0, the switch is closed, and the capacitor. This is a VT. This is an output voltage over here. But we want to know that voltage. And the capacitor, and this is a Vs. And this is input. Then, in conclusion, input is sinusoidal. Then output is sinusoidal. We'll discuss about it later. Maybe in the end of this chapter, we'll derive when the input is sinusoidal, output is sinusoidal. Input is constant, output is constant. Input is exponential, then output will be exponential. We will deal with we will derive why it is. So we need to define electric circuit based on the time. We will discuss in the chapter 7 in the last part, in the sequential switch circuit. So when first T is smaller than 0, then this circuit looks like here. This okay here. So this is R1 and R2. This is VT and Vs. So because Vs is given A cosine 1000 T plus theta, and because the source is sinusoidal, the output will be sinusoidal. So what and what is the value of here, but Vt output value is another cosine, but the frequency, this is the frequency is the same, T, but the pace will be different here, and value is B will be different. Then from here, the reason we will discuss over here is, I will later. I will tell you. I will explain later. Second, when T is larger than 0, because the switch is different, so we will rewritten the circuit here. It's a little different here. Now this is only R1, then this is VT and Vs. So because this is after, and this is a circuit after switching closed. So because of this is abrupt changing indicate in this circuit. So anyway, there was some the transient from this circuit, from this circuit and this circuit, we have some transient. In Korean, 과도 상태. So the solution of this VT consists of transient part and steady state part. Actually, this is a steady state part. Why? This circuit is maintained from the minus infinity time to the 0. So time is very huge long. So now the state of the very steady state. But because condition is changes in very instantly, so there is an transient response here. So this voltage has a transient part and steady state part. So this part will be eventually die out. This is transient, and this is a steady state because the source is sinusoidal, so that will be sinusoidal. So the reason we know this circuit, this solution is actually we don't need exactly their values. The reason to redefine that value is to get an initial condition. So when switch is closed, I mean there are some dramatical change in the circuit. Then we want to know what is the initial condition of this circuit. So in this case, we need to know the initial condition over here. In the case of capacitor, we should know the Vt is 0 plus. But actually, we cannot solve this equation, this electric circuit, because we don't know. But we have very important fact. What is that? Voltage of capacitor does not changing discontinuously. I mean, the voltage of capacitor is continuous. The same way, the current of inductor is continuous. So actually, we can gather V when t is 0 minus. What is that? We insert here, then we'll use B cosine phi. Because voltage capacitor does not change instantaneously. So V 0 minus will be V 0 plus. So we know that will be a initial condition of this electric circuit. So we need to know about here initial values, initial condition. So generally, because source is continuous, sinusoidal, so the steady state part will be continuous, sinusoidal. So mem cosine 1000 t plus another phase. And because this circuit has only one capacitor, this is the fourth order circuit. In general, actually it's not general, it's always the transient of first order circuit is this type of here, exponential. This is a general form of transient part of the first order circuit. So Vt looks like here. So we need to know, to get the V is, we need to know M and delta and tau and K. So actually this is the general form of the first order electric circuit here. But by using the KCL or KVL, we need to find out tau or M and delta and K will be obtained by using the initial condition later. So anyway, this is the form of first order, the voltage circuit, the voltage. This consists of transient response and steady state response. So solution of different equation, the complete solution, it consists of transient response and steady state response. The same things. Another name is natural response and forced response. This is the same meaning over here, and this is the same each other. So another solution name is general solution and particular solution. And particular response, homogeneous response, non-homogeneous response, homogeneous solution, non-homogeneous solution, there will be a that velocity. Same things. Same thing, different names. This is the same thing and different names. So I will give you the very general form of first order circuit. This is very important. I recommend you remember these. I mean, you need to study it very carefully. I will give you the briefly how to solve the first order the differential equation. I'll give you here the general form of is here. We'll deal with t, dt, d or dt, xt, and axt equal fx. So actually, x will be voltage or current in the circuit, and f will be the source. It could be a voltage source or it could be a current source. Anyway, here. Then we first know the two. Actually, our goal is we need to know xt is what is xt. That is our goal over here to get the xt. That means we will solve the first order the differential equation. Then we already know about the xt is a natural response plus forced response. So first we will get natural response. What is a natural response? Actually, natural response is a solution of this here is a homogeneous solution. What is homogeneous solution? That is dt dxt plus axt equals 0. This is homogeneous solution. Homogeneous solution is a solution of this equation. So in this case, when we define xt is k exponential minus dt dt minus t0, this is a general homogeneous solution of first order differential equation. So we can choose it. Then we need to check it. If this is a solution of this homogeneous equation, then we add in here. So we need to check this is right or wrong. So dt d k e minus dt d. Oh, sorry, this is wrong. I have a mistake here. And this is not 1 over tau. 1 over tau t minus t0 plus a k exponential minus 1 over tau t minus t0 will be 0. If this is a solution, then this equation should be satisfied. So first we'll do here okay, we need to deliberate based on t, so there will be minus 1 over tau, because this is exponential. So exponential minus 1 over tau t minus t0, and plus a k exponential minus t minus t0 will be 0. So the same common things, and this is the common things. So what should we do? A minus 1 over tau k exponential minus t minus t0 will be 0. So if tau is 1 over a, then k exponential tau t minus t0 satisfy homogeneous equation. So we can use that this is a general form of the homogeneous equation of this first order the differential equation. What is the condition? The tau is 1 over a. Then what should we do next? We need to know the first response. So based on here, we get the general form of that. General form of that is k minus 1 over tau t minus t0 is a general form here. And first response, we will deal with it later. Maybe the last part of this chapter we will deal with about here. The common response is determined by source. The source is in here is fx. So fx is constant. Then first response xft is constant. And then if this is sinusoidal, then that will be sinusoidal. And if there's exponential, then that will be exponential. Is it true? Yes, it's true. We will, in last part of this chapter, we will derive why this is justified here. So then, this is get this type here, and this will be calculated based on the elliptic circuit. So we can get the xt. So we'll summarize how to solve the first other circuit. The first, we have to find out the steady state before disturbance. Actually, the reason we get the actually we does not need to get the steady state before the transient, in the step, the switches changes. Our concern is that after switch is operated, then voltage or current is our concern. Even though that we should know the steady state before disturbance. Why? The reason is to find initial condition of inductor or current or capacitor voltage, because that is the starting point to get the voltage or current in the electric circuit. Then we have to find out the steady state after disturbance. That is the reason to find the first response. So we feel the complete solution. What is complete solution? It's natural response plus steady state response. So we get the steady state response from here. Then our natural response is a general form here. Here we need to know the tau is 1 over a. So a is derived from the electric circuit. Then we know the tau, because tau is a parameter based on the inductor or capacitor or the resistor in the circuit, and that will be written based on the KCL, KVL. Then we have one more unknown variable, that is a K. And K can be calculated based on here the initial condition. We insert initial condition here and to get K. To find K, the natural response using initial condition. Let's just step to solve the first order, the circuit in here. This is a first order circuit in the case of the constant input. So we will do this here. Maybe this is your first example about to solve the first order, the electric circuit. This is the first step. In this chapter, we will deal with the circuit. The circuit has a source, which is a constant input, such like 5 volt, 10 volt, whatever it is. In the case, we will study with the voltage. So here. Then we say here, we will solve. The target is we need to know is VT. So what should we do? At first, VOC will be same with this voltage is LTI plus this voltage V. Actually, we insert T. We think the T is, that means this current and this voltage is different based on the current. So because this is a capacitor, so we know the characteristic of the capacitor. What's that? This is I, IT is C, DTD, VT. So we're adding here. Then VOC will be LT, C, DTD, VT plus VT. Then this equation can be rewritten here. DTD VT plus 1 over LTC VT is VOC divided by LTC. What is that? What is that? You remember that DTD XT plus AXT is YT. This is a general form of first-order differential equation. The same way, when say XT is VT and A is 1 over LTC and YT is VOC LTC. Because we use the constant input, then this is constant, so the input is constant. So this is a first order differential equation. How to solve the VT? Our target is VT. How to get it? How to get it? We use VT will be, what's that? What was V there? Natural response plus forced response. So what's the general form over here? K exponential minus no tau t minus t0 plus what's the forced response? We will calculate it later and get it. So anyway, this is the way how to solve the electric circuit, which has the one capacitor or one inductor. In the case of the first order circuit with constant input, we will have more the general solution. It's like here. This is how to solve this type of electric differential the equation. So we will use separating the variables. In Korean, this is 변수 분리법. So when you have dtd xt plus 1 of tau xt is just some constant value of k. Then we will use separating the variables. Then we move here dtd xt is k minus 1 over tau xt. So there will be k tau minus xt over the tau. Then we move here and we move there. So what should we do? Then k tau minus xt and dxt is same with dt tau. Then what will we do? We'll integral in both sides. Integral minus infinity to t k tau minus x. Anyway, we use a t, so we will use a different. Maybe anyway, we will use t, but I will change it. This is a t. dxt dt will be integral minus infinity to t tau tau dt. Then oh no, I'm sorry, we don't need to do that here, because the t we don't need this here because we have here. So actually, because we integral based on dxt, so that will be to rewritten more exactly x minus infinity to xt this way here. So that will be, because this is one of that values, so there will be ln x minus k tau. Then this is one of tau t, so there will be because when time is infinite then it's 0, so that will be minus 1 over tau t plus integral values here. So to get the xt, the x minus k tau means exponential minus 1 over tau t plus d. There will be exponential minus 1 over tau t and exponential d. So we change a is exponential d, then there will be exponential minus 1 over tau t a. So x will be k tau plus a exponential minus 1 over tau t. Then we need to know some values. What is that? Because xt is k tau plus a minus 1 over tau t. So when xt is 0, this is initial condition. That means this is k tau plus a. So from here, A is rewritten x0 minus k tau. So we add in here. So xt is k tau plus x0 minus k tau exponential minus 1 over tau t. Then if x is infinity, then what happens here? That means actually exact expression is t, then t go to infinity, then what happens? That will be, this will be 0. Why? Is here. So there will be k tau. So we rewritten xt is not kt. Kt can be replaced x infinity plus x0 minus x infinity exponential minus 1 over tau t. Here. So this is the total, the complete solution. Of first order differential equation. In the case, this is about satisfied only useful at constant source. That means y-x is a constant value m is like here. Then you can use this equation in general form. Then we need to know about what is the meaning over here. We can get some insight of this equation. It's not difficult. It's not difficult. You see, xt is the general complete solution of x. Then that is a value of what is on here. That is a steady state. And this is a natural response. This is caused by the state change, like a switch or other things. So you see, exponential minus 1 over tau t. If tau is positive values, then my exponential minus t tau t, when t is infinity, that will be 0. So that means these natural response will decay to 0. This is a very very valid when very short time for the transient. I mean, if for example, if there are some circuit here, voltage Z and here and light here and switch here and capacitor here, then based on this operation of switching, the circuit is changed from here and here. Then our target is V here. It's V. So initially, when t is 0, t is wrong. So at the time, V value is V all. For example, this is 10 volts. Then when it is 10 volts, anyway. But later, that value is different. Like for example, voltage is at first here. Its voltage is actually Oh, sorry, this is a different example. This is not exact. Voltage of source is T. Before T is 0, that value is 10 volts. Then after T, that value is 20 volts. Just like over here. Because here, this 10 volts, so V0 will be 10 volts. Then in this instance, the voltage source is changing from the 10 to 20. So V infinity will be 20 volts. So capacitor voltage will be changing from the 10 volts to 20 volts. This is a steady state. This is a steady state. But the difference thing is, this is a steady state from minus infinity to 0. This is a steady state from the 0 to infinity. So voltage VC will change here. That value is changed from 10 volts, this is 0, go to the 20. Then you already know about that capacitor voltage cannot be changed instantaneously. So even though 20 volt is a general steady state, but they cannot happen. So what happened here? Maybe based on the resistor and source, there will be some transient between this area here. At this time, voltage will increase in this way here. So that is a complete solution here. Then we can think about this will form here. Is in here. This is a 20 volt here, and there will be some voltage here in 0. Here, this is right here. So this waveform is a sum of this and this. This is 20 volt, and this is maybe this decade. That value maybe there will be about minus 10. The minus 10 exponential minus tau t. So this is a forced response here. This is a forced response, and this is a natural response, or the transient response. Same things but different name. So the system is different in some instance. Then after that, the voltage or current has some transient, such like here. So total complete solution of voltage or current is reprinted here, but that is a consist of forced response and this like a natural response. So this is the why we have to get the natural response and the forced response separately. So that's the meaning of the forced response and the natural response, or the transient response. So this is the reason we are called is a transient response, because this is a transient. Transient in Korean is 과도 상태. 과도 상태 means some very temporally a response. It's not. This is just for temporally, because of change of the status. So we will do this in one example here. So this is a more simple solution here, but this solution is a different approach. I will I already tell you how to find out the composition issue here. This is good. This is good. But when you want to get the depth values here, if the source is a constant, then you can use this equation. This is a different approach here. So this is example of here. I will give you a solution step by step. Find the capacitor voltage. After switch opens. So circuit is looks like here. This is 8 volt. This is a constant source. It's very simple. And this is a 10 kilo ohm capacitor. And the switch here. And this source and two sources here. It's 2 volt. And this is a VT and it's 2 microfarad. When T is 0, switch is open here. So our goal is to get the VT. So what should we do? Our concern is after T is 0. So, but it's a capacitor, but we want to know what is the value of Vt is 0. This is the initial condition. So to do that, we define the different circuit here. First solution, T is smaller than 0, then circuit looks like here. Because this is a short, so there will be 10 kilo ohm, and there's a capacitor here. There are 2 volt here. So we don't need to get this solution over here, but we just need to know where's the VT will be. This is a VT. Is 2 volts. Why? This is a state. We call this is a so from here we get the V0 minus is 2. Is 2. This is initial condition. Then we should do that here. We should know when T is larger than 0. Then because switch is open, so circuit will be a little different here. Plus minus 10. There's only one capacitor here. Because switch is open here, so we don't consider here. So this is VT. This is a C, and this is R. Maybe C is 2 microfarad, and R is 10 kilo ohm. Then there is VS. And VS is 8 volt. Then our goal is to get a VT here. So this circuit we should solve here. Then we will use simple things. What should we do? We use any KCL or KVL, whatever it is. So we will use the Kirchhoff's voltage law. So because we look here, voltage law like that. Then we define this is IT here. Then the voltage is RIT. Then what's that? Minus VS plus RIT plus VT is 0. So, and we have the capacitor equation. What is that? IT is C dTd VT. So we insert it here. Then Vs equal R C dTd VT plus VT. We get the first order, the differential equation. Then we rewrite more simply, mostly. dTd VT plus 1 over R C VT will be 1 over RC Vs. You know, then we know that Vt is the V NT plus V FT. VNT means natural response. And VF means force response. Then at first we will do that. What is a VNT? So we know that the general form over here, K exponential minus 1 over tau T. Already we discussed about here is not, what's that? T minus T0. T0 means is a start time of this circuit. That means that time instance, the mode is changing, state is change. So in this case, the switch is opened at the T is 0. So in this case, T0 is 0. So there will be K exponential minus 1 over tau T. And base here, from here, we get the 1 over tau is A. A is 1 over RC. So based on here, we get the K is minus RCT. Okay, here. Then we need to get the VF. What is a VF? VF is the first response, I mean the state response of this circuit. When time is go to infinity, then this state, then what happened? Then V is constant. So we can redraw the circuit is Vs R, and this is open. Why? In the constant, I mean infinite time, the capacitor is open and current, I mean inductor is short. So there will be no current here. So Vt will be Vs. So there will be value is 8. And RC is, R is 10 kilos. For C is 2 micro. Then there is 0.02. So here we get the Vt is, Vn is K exponential in here minus 50t and plus VF was 8. The only thing we have to know is K. The K can be obtained using the initial condition. So initial condition was 2. So V0 minus is the same with V0 plus is 2. So adding here, so V0 is 2 go k, because t is 0, then that will be 1 plus 8. Therefore, k is minus 6. So, composite solution Vt is minus 6 is equal to minus 50t plus 8 volt. That is a solution of here. So this is a solution of this circuit. So waveform over here is this. You need to think about here. When t is 0, smaller than 0, then Vt is what is that? Is 8. Is maybe this is 2 volt. T is 0. And t go to infinity, then that value is 8. So we know that Vt is 2. It's 2. I will later. Okay. Let me draw here. T. At first, V is 2 volts here. And later, that value will be 8. But in some area, there will be some response. It's like a transient here. So this waveform can be written here is from this area, there is a here 8 and that this is minus 6. So this is V F T and this is V N T. V N T is minus 6 exponential minus 50t and VF is 8. So this is a forced response and this is a transient response, natural response. So that's like here. This is a complete response of this voltage of capacitor. This is the way how to solve the first order circuit. What is that? Recall, we summarize here. What should we do? What's that? First, we need to know the initial condition of it. In the case of inductor, the current. In the case of capacitor, we need the voltage of initial condition. To get that, we might make a simple circuit when the disturbance is before. Then we make the electric circuit after disturbance. The reason is we need to find out the fault response of the circuit. Then the composite solution is very simple. We make adding the natural response and steady-state response. But we already know about the general form of electrical response of the first order circuit. So based on, to get the tau, we make one simple, the first order equation. We make a drive this type of voltage equation from the circuit, Ft. Here we get the value of this. This is a parameter based on the capacitor or the inductor or the resistor in the circuit. Then we already know about the values. We know their values. The only remain unknown thing is the K. K can be obtained using this initial condition here. So So we insert in the condition this equation and get the K. So we get the complete express. That is a simple way. Actually, this is not only the first order circuit, this is also the second order circuit. You can use these steps. Only different thing is, if you solve the second order circuit, I mean, electric circuit has a one inductor and one capacitor, or two capacitor or two inductor. That will be a second order differential equation. The only different thing is, because this is second order, we need to know about two different initial conditions, and the choice transform is a little different because the circuit is a differential, I mean second order differential equation. Except of 2 points, this procedure is the same, even though the circuit is second order, the differential equation. So you need to familiar with this process to solve the first order circuit.